good morning, and today we will discuss about this gear tribology. So you must have learned about gear design, but here we will be focused on the tribology aspect of gear design. So generally any kind of drive like belt drive, chain drive or gear drives are used for power transmission. Power transmission over a distance, right? So for example, if the power is being produced here through the prime mover like a motor, so but we need this power at some point here, let's say at a different point here. Okay, so since this is not this has got some shaft, the motor has a shaft and shaft is rotating, so but we need the power here, so we will have a drive here, so a shaft, then here we will have the gears, and here we will have another gear, so driving gear and the driven gear, or they are also known as gear and pinion. So they will be engaged, so they will be totally engaged, and this shaft will now rotate. So this is the principle of power transmission in gears. So this is just part of the overall mechanical drives which are basically used for transmitting power and also for changing speed and torque. Power is transmitted and then speed and torque can be changed. So gears are defined as toothed wheels or multi-lobed cams which transmit power and motion from one shaft to another by means of successive engagement of teeth. So we may have several of these kind of gears for proper transmission of power and speed and torque. So depending upon this we can have a gear drive train. So basically we will focus on this, the gear engagement, and how the tribology plays an important role here. So toothed wheel designed for transmitting motion and power from one shaft to another when gears in both shafts are suitably engaged. So these are the advantages of gears. So as I said before, that we can transmit power using belt and chains as well, but belt and chains have some limitation, and so these are the advantages of gears: positive drive with constant velocity and compact construction. So this is a very important part, that the gears can be designed in a very compact. So for example, gear boxes are designed, and so for example our automotive systems, our cars have got these gear boxes and they are very compact and we can use them very effectively. So imagine if these gear boxes were not there and we were going to use belt and chains, it will not be compact. But for smaller machines like a bicycle we can use chain drive, but for equipments where the speed is very high, we need to have the gearboxes. Large power transmission, so no slippage or breakage as for belt and chain drives. So this is another advantage. We do not have the problems of any breakage. The power can be transmitted in very large amount. Low speed power transmission, which basically means that at low speed some power transmission may not be possible. For example, belt drive cannot work at low speed. So belt drive will have some slippage, whereas in the case of gears we will not have any slippage. So that is another advantage. High efficiency of power transmission, so there is a very minimum loss as long as you have other bearings properly done, bearing design, then you will have very little loss of power, and especially for spur gear you can get as good as 99% power transmission, so no loss of power. High velocity change possible over a wide range, so velocity change possible over a wide range, so that means we can go from very low speed to very high speed. So this is also known as gear shifting. So but there are some disadvantages. One disadvantage is it is very costly, so gears are very costly compared to other drives, and the maintenance require lot of, again, cost. Maintenance also costly because you need to change the oil, gear oil, and you need to have proper material. So materials are very, very important in this case, as well as lubricant cleanliness is very important. So lubricant in general is very important for gears. And also another we can call it a disadvantage is alignment is very, very important, because if there is misalignment then gears will not work, there will be a lot of wear, and that is part of the tribological issue, that if alignment is not good then you will have tribological issues. So these are the advantages and disadvantages of gears in our machines, and there are several types of gears, for example spur gear, helical gear, then bevel gear, worm gear. So we will talk in general how these how the tribology plays role in the case of gears. One thing we should know is, for example, in a spur gear the contact starts with a line, so contact between the tooth of the gear part and the pinion. So the driving part is called gear and the driven is the pinion. So the initial contact between them, between the teeth of these two gears, will be a line. Okay. Whereas in the case of helical, it starts with a point, just one point contact, and then it becomes a line. So there is a gradual increase in the contact. So this gives some advantage. So this type of gear can be very low noise and high speed. It can work at high speed because of this reason, that the load transfer happens gradually because the contact is gradual. Now here we have got some terms which are used in gears, so I think you must have studied before. This part is addendum, the top part here, and this part is dedendum, the bottom part here. This is the width of the gear, face width, circular pitch, so this is the pitch part. Okay, so our main worry will be about the wear that is taking place in the addendum and the dedendum part. So we will see how the problem and the tribological issue in gears, and when we know the tribological issues, then we can design the gears so that we can avoid those tribological issues. So one thing we should notice is that in gears, when gear is working, there will be sliding contact, there will be loading contact, and there will be bending of the teeth like a cantilever. So all these kind of, for example, sliding contact will cause wear, different types of wear, adhesive wear, abrasive wear, third body wear, okay, as well as some surface fatigue also can happen. The rolling contact will also cause surface fatigue because of the Hertzian pressure or Hertzian stress. And bending of the teeth, like a tension and compression, will cause general fatigue. So these are the main issues and how we can avoid these issues. So first of all,
Excuse me, sir.
yeah,
Sir, when the sir, two gear in contact, so sir, there is a line contact. So sir, pressure is very high. So pitting effects are also considered.
yes. So pitting is part of that. So pitting will happen. Yeah. So
But
because of,
sir, you don't consider.
yeah. So surface fatigue is basically pitting, right? It will lead to pitting.
Okay, sir.
Yeah. So we should try to understand how the sliding and rolling takes place. So for example, this is the driver gear. So for example, it is moving this direction and this is the driven part. Okay. So this is the pitch. So below the pitch, the the diameter is less. So distance, so the surface speed or the speed of these parts are smaller compared to here. So there will be speed difference. Okay. So there will be relative motion. So if two surfaces are moving at, let's say this is moving at certain speed and this is stationary. So in that case, the relative speed is the speed of this part. If both are moving at the same speed, in that case, relative speed will be 0. If they are moving at the same speed, then relative speed is 0. But if they are moving at certain some speed, but those speeds are not same, so then we will say, let's say v1 and v2, then we will say v1 minus v2 is the relative speed. Okay, so there is a relative speed and that leads to sliding. So there will be sliding here in the dedendum part of the driving gear. As soon as they come in contact pitch to pitch, when the two pitch are in contact, okay, so there will be no relative speed, so there will be pure rolling at that point. And then again, as it goes away, so this is the meshing part, and then it goes away from the mesh, then again on the addendum part of the driver and dedendum part of the driven, there will be sliding. So this is the main cause of why sliding takes place and how sliding and rolling. So at each point there will be certain amount of sliding and certain amount of rolling. So as it goes towards the pitch, there will be pure rolling, no sliding, and again going back, again there will be sliding. So rolling and sliding continues. Now another thing is, as the power is being transmitted, the huge amount of force is being applied. So when this driver applies force here, so you will get here compressive stress and here tensile stress. Okay. So similarly, this will impose force, the reaction force on this one. So it will push in this direction. And because of this, there will be compression here and there will be tension here. So both teeth experiences compression and tension at their bases, experiences huge amount of sliding, and experiences huge amount of Hertzian stress, which leads to fatigue. So these are the main causes why the gears will fail. So gear teeth initial engagement and final disengagement involves sliding, and at the pitch line the contact is purely rolling. So this has been shown here in a schematic way, but just now I have explained to you how sliding will take place, rolling will take place, and again sliding will take place. So basically the three things we have to take care: the sliding part, the rolling part, and the bending part. So how can we design gears? What kind of things we have to do so that we can avoid failure because of this? Okay, so when we are designing gear, we also take care of the material part. The material part is very, very important. So what kind of materials we are using to make the gears, and then comes the lubrication, because since sliding is taking place, proper lubrication will help to reduce the surface stress. Okay, similarly, proper lubrication at the rolling contact will help to distribute the stress and cause less damage to the material. So materials and lubrication, and as well as another important thing is alignment. That means manufacturing part, alignment and manufacturing. So manufacturing is also the manufacturing of the gear itself. So there can be some defects and damage in the manufacturing. So as well as the shape, the involute shape of this gear tooth is also extremely important. Otherwise, these actions of sliding, rolling, and bending will be increased, and therefore failure will be possible. So in the gear business, there is a called AGMA. AGMA, this is the standard, American Gear Manufacturers Association Standard 2001. So this standard, it is available on the internet, so you can use this standard to understand, to calculate its rating. So for example, wear life rating. So you can compare between different gears, their wear lives, and which type of gear will be good. In general, smaller teeth improves wear rating. Improves wear rating. So design of gears requires avoiding the wear of the gear addendum and dedendum areas. So this is very important. Pitting, avoiding pitting due to Hertzian contact pressure or stress. So pitting can happen both during the sliding as well as during the rolling part. Plastic deformation of gear teeth. So if the material is not suitable and the stress is extremely high, there will be a gross plastic deformation of the gear teeth, and that will lead to adhesion and failure. Gear teeth breakage due to fatigue loading. So since the base of the gear tooth experiences both compression and tension load, so that means there is a huge amount of stress variation, therefore it will lead to fatigue or bending and fracture. Then we should also avoid corrosive wear, because if the environment is not suitable, there is a humidity or there is some other chemicals, then the gears will corrode, and that will lead to failure. Then third body abrasive wear. So cleanliness is very important. So most of such kind of gears, especially in automotives, they are put inside a box, gear box, and they are kept away from the environment, okay? From dust and any kind of impurities. So they are maintained clean. So cleanliness is very, very important. Otherwise, it will lead to third body abrasive wear. So basically, the gear life will be affected by load, then load distribution, materials, also temperature, lubrication film thickness, and the geometry, the finish, and the hardness of the material. So gear materials are generally, you will find in olden days we started with wood was used, but later bronze and cast iron, then different types of steels are used. So when we talk about the steels, they are hardened and also unhardened. That means just normal without hardening. And then nowadays plastics are also used, plastic gears. Okay, so these are the main materials which are used for making gears. And another thing is about the hardening. Okay, so the hardening can be done both as case hardening or through hardening. So in the case hardening, basically we will do the hardening on the top part. So this shows the cross section of the gear tooth, and hardening is done on this part. So this is known as surface hardening or even case hardening. This is called case hardening or surface hardening. So in this case, the hardness is increased for some distance starting from the surface, so maybe a couple of millimeters, and it is extremely hard, HRC in the range of 60 Rockwell hardness, whereas the inside the core hardness will be in the range of 40. So this is the hardness of the case, this is hardness of the core. And in the case of through hardening, that means we have done the hardening throughout the material. It is not only the case, but throughout. But in this case, the hardness is kept HRC in the range of 40. So why in this case hardness is not increased? Why can't we just increase the hardness of the whole gear to, let's say, 55 to 60?
So because we're doing whole hardening, no, whole parts same time.
Sorry, can you say again?
So because we did whole parts at the same time.
Mm-hmm.
So that is the reason.
Yeah, but what will be the problem if I harden this to 60, the whole gear?
So I think sir we require at the for the part as sir it's face and flank are doing the work. So we require that part should be more harder than
Mm-hmm.
inner one.
Mm-hmm. So another reason is that if the surface if the whole material is very hard, then it also turns into brittleness, and because of high hardness the whole material will be brittle, and it will lead to faster fatigue failure. So in fact case hardening will be better, because in this case you have got very high hardness on the surface, so it will protect against wear, but core is very tough, so toughness is one important factor. So toughness of the core must be high. So if we increase the hardness to more than 50, then the toughness will reduce, and therefore the failure will be because of the fatigue loading. So case hardening is generally good. It can allow you more power transmission, and that's why most of the especially mobile equipments like mobile machines like cars, they have case hardened gears. But the tolerance requires closer tolerance in manufacturing. So any kind of misalignment or any kind of impact loading will lead to this breakage of this case, because the interface between the case and the core has some residual stress, and therefore the crack initiation and propagation will happen along the interface, and this kind of case can be removed. And once this fragment of the case is removed, then that will act as a third body and the wear will take place. So wear will become very high if the case fails. So that is very important. The alignment is important and there should not be impact loading. Whereas the through hardened gears are more tolerant for even some misalignment, because in this case there will be no problem of the case material coming out, and this, even though this may be wearing out, but still it will work. So now we will go through some of the wear mechanisms that happens in the case of gears. So first wear process that takes place is polishing. So slow wearing in, asperities are worn out, giving very smooth polished surface. So this may be a good thing. The initial wear may be good things. It will take care of any kind of asperities. So initial asperities will be worn out, and very minor misalignment may also be there. So initial polishing is good. That helps to, so that the gears can mesh together nicely. Good for the gear surface, provides good conformity, so the contact pressure can be reduced. So any kind of, because of initial polishing, the contact pressure can be reduced, reduces localized stresses. So initial polishing wear is good, but during the polishing wear you can also understand if there is a misalignment, because misalignment will lead to irregular type of polishing. So polishing wear is not bad, but initially it will take place and it will lead to very shiny smooth surfaces. The second part is moderate wear. So metal removed from the addendum and dedendum areas over a long time, so it takes some time. So this is not a sudden wear or catastrophic wear. It is slow wearing process and over a period of time. And as I said, it is because of the sliding that is going on between the teeth, caused by inadequate lubrication. So lubrication is not good. That means sliding will be more damaging. There will be high surface stress. So we need to have good lubrication and thin lubricant film or presence of dirt. So if the lubricant film is not thick enough, so in this case it will be the EHL, elastohydrodynamic lubrication, or HL as well, so depending upon the speed. So these are the lubrication mechanisms that will work. So if the lubricant film is thinner, then there will be solid to solid contact, and if there is a presence of dirt in the lubricant, that will also lead to moderate wear. So obviously the solution will be changing the viscosity of the lubricant to higher one. So if the gear is failing because of moderate wear, then higher viscosity lubricant, increasing the speed for hydrodynamic film formation. So sometimes if it is possible, we can increase the speed. Filtration, filtering the lubricant is very important, and that's why the gear boxes, the oil in the gearboxes are changed frequently to help it remain clean. And another is increasing the hardness of the gear material can also be tried. So this is another solution. So if the gear is failing because of moderate wear, so you see that the wear is not just polishing, it is more than polishing, and material is wearing out. So we can try these kind of solutions. Or during the design stage itself, we should take care of this one. So we should ensure that material hardness is appropriate. We should ensure that the lubrication is good, both the base oil as well as the additives, and also we should ensure that the speed and the viscosity of the lubricant.
Hello, sir. So, sir, but in moderate wear we have we're doing as a hydrodynamic lubrication. So, sir, we have constraint now. So we have to make a closed chamber in which we have to put gear and continuously circulating lubricant. So we cannot use in many of the cases, sir.
Mhm. So we have to continuously circulating, but it is inside the case itself, right? Not like engines where the lubricant is collected in the sump and then filtered and then goes back. For example, in the car gearbox, the lubricant is continuously purged inside, but it is not circulated and filtered. So therefore, we need to change the gear oil after some time.
Yes, sir, but also it limits our application, no, sir.
Yeah, it limits our application. So depending upon the severity of our stress and speed, we have to find a solution. If the stress and speeds are not that high, then perhaps just grease can help for long-term application. But if the speed is very high, stress is very high, and that will lead to high temperature as well. If temperature is also high, then we need to have proper solution for lubrication, as well as we need to start with a hard material, so hard material of the gear. And third type is excessive wear or drastic wear. So severe wear takes place in addendum and dedendum to the point that involute gear profile gets destroyed. So the profile gets destroyed, just like here you can see that some new things are coming up. This is caused because of the failure to notice early wear signs. So obviously, if the moderate wear is taking place and if you leave it in this situation, if the wear rate quite high, then it will lead to excessive wear. So pitch line will be prominent with some signs of pitting. So since wear is taking place in the dedendum and the addendum part, so therefore the pitch line will become very prominent. Okay, it will be visible. The remedy is same as for moderate wear case: better lubrication and better lubrication direction. So we should have some lubricant feed, so positive feed for splash lubrication, and lubrication filtration should be adopted. So filtration, either we can have a continuous filtration or we can have gear oil change so frequently. So these are the drastic steps we have to take if the excessive wear is taking place, and depending upon application and cost, we can decide which solution we should adopt.